Hi everyone, it's great to be talking at DataTech this year, and my name is Angus Addlesee. I'm going to talk today about how to adapt voice assistants for people with dementia and people affected by sight loss. I'm a PhD student at Heriot-Watt University, and this project is funded by Wallscope and the Data Lab. So voice assistants, this one's Google Assistant here, but you're probably familiar with at least one of them, maybe Siri, Bixby on phones, Amazon Alexa, etc. And they're a lot more common today, and they're really great for stuff like, if I'm making a pizza, I've got flour all over my hands, and I want to ask, can I set a timer for 2 minutes while my hands are dirty? I don't have to clean my hands, I don't have to get flour all over my phone, and just use my voice. But there are certain groups where this is particularly helpful and really can benefit people's lives quite significantly. For example, people with dementia can enjoy their music more independently. The picture there on the left is a screen grab from a video from a charity called Playlist for Life. It's a fantastic charity that I'm collaborating with at the moment. And this picture here, it's a wee couple. It's a tearjerker. I really recommend going and watching Playlist for Life's videos. But essentially, they find that music is really beneficial. I'm not a neuroscientist, but it helps with people's mood. It helps people become more talkative, especially in the later stages of dementia, and it helps couples connect. It is really beautiful. But often people listen to music on MP3 players, remote controls for their stereos or their record players, and maybe tablets, for example, with lots of buttons. And another symptom of progression of dementia is sort of hands shaking a bit, and also getting confused at these interfaces with lots of buttons. So we wanted to find out whether people with dementia can access their music more independently with just their voice. And in fact, I've got an example of a gentleman I was working with recently who found that he found new music from artists from when he was young. He'd listened to all their albums. He had so many albums, but he could just ask for them with his voice, and he listened to new music and found new favourite songs from these artists that he never would have heard, and he absolutely loved it. He could just sort of sit and listen to his music without having to get someone to come and help him finding the music he wanted. It was really fantastic, and hopefully the results in the end, hopefully find others find the same. Another group I want to talk about are people affected by sight loss, so blind and partially sighted people, for example. So computers can now, it's called computer vision, they can sort of see and they can interpret what they see through their cameras. For example, this image on the right is a screen grab from someone called Joseph Redman. He's a computer scientist, very good at computer vision, and you can see that his algorithm there is detecting the car, the bike, and the dog, and doesn't just know they're in the image; it knows exactly where they are in the image, and it can sort of annotate that. So if people affected by sight loss can ask about their visual surroundings with just their voice, if we integrate this sort of computer vision, that would be really fantastic too. So there's 2 examples of specific user groups that can really find a big benefit from voice assistants. So sometimes people pause longer than expected, and even though I started this sentence with some repetitions, self-corrections, you can all understand exactly what I'm saying as I say each and every word. And this is true sort of in everyday conversation. We listen to words as they're generated from our speech, and we can handle sort of pauses and ums and ahs and yes and mhms, etc. And yeah, we can handle stuff like the thing on the wooden thing. None of you maybe understand what object I'm talking about right now, but with an image, the thing on the wooden thing, you all now know exactly what I'm talking about, that laptop there. And that's because we don't just chat using words, we nod and make eye contact. So I would pick on the audience usually here. I would looking for people that are looking at me and so if they could understand they're engaged, people nodding, understanding what I'm saying, people on their phones who are maybe less engaged, and people that are laughing at my incredible jokes. So we don't just chat using words, we use these visual cues as well. And this phenomena we all sort of subconsciously handle as we're talking to each other. So maybe try and look out for a couple of these while you're having your next conversation. It's kind of fun. But dialogue changes as cognition declines, and these phenomena, these conversational phenomena that I'm talking about, they become more pronounced. So pauses, for example, become more common as dementia progresses, and longer as well. So as someone maybe forgets the word they're looking for. And another change, for example, is they use anaphoric expressions. So they'll say, "Can you get me the thing in the oven?" rather than "Can you get me the chicken?" Because they forget the word for chicken, and instead of pausing, they will sort of just navigate around that by saying "the thing in the oven." And we find this from sort of current data. But there are two major challenges, I would say, into adapting voice assistants for people with dementia. And why should we adapt? Why should the system adapt? Well, currently we adapt to the system. So if I say, "Alexa, set a timer for 2 minutes," it's a perfectly normal interaction. I don't think any of you would, "Whoa, that's terrible." But if I said, "Mum, set a timer for 2 minutes," it's very robotic. It's rude, in my opinion, anyway, and it's very unnatural. It's not how we would talk to another human being. I would maybe say, "Oh, my hands are wet. Can you just chuck on a timer for, I don't know, a couple minutes?" And I've tested this with the systems. They don't understand that interaction there. So they require this very clean speech without these phenomena that I was just talking about. So if people with dementia, as dementia progresses, they use more and more of these phenomena, and these current systems can't handle these phenomena very well. Instead of adapting to the system, can we adapt the systems to specific user groups? And as I mentioned, there are two challenges identified that are really vital to tackle, and that's lack of data and the unnatural interaction. So these two challenges we found were published in a paper at Dialog for Good in 2019. It was obviously more detailed than these 2 points, but these are the main two takeaways. So the lack of data. Current voice assistants are trained on millions of hours of people's speech, but this is very clean. It doesn't have this conversational sort of phenomena that I'm talking about. Some of them do have a bit, but many of them use large data sets of people reading tokens. They'll say maybe a sentence saying "this is a spoon," and the person will say "this is a spoon," very cleanly. They will not say "this is a spoon." That would get chucked out. It's not correct. They didn't read the label correctly. So a lot of the data is very, very clean. And it's not from specific user groups that you're wanting to adapt the system to. So conversational, spontaneous conversations between people with dementia and others, it doesn't really exist. There's sort of interviews and monologues, that kind of thing. And the second challenge there is the unnatural interaction. So there I'm talking a lot about this sort of turn taking. So Siri, for example, will go beep beep, and it's your turn to speak. You say set the timer for 2 minutes. It then hears the pause and it calculates, and in that time you can't say anything. It's processing, and it will do what you've asked usually. But let's say I was at a travel agent and I said, can you show me all flights from Scottish airports to Paris tomorrow? No, Berlin. The travel agent, a human travel agent, would start and then very quickly go, "Oh, Berlin," and give you the results that you were asking for. A system like Siri, for example, where it starts processing, it hears that pause, it thinks you're done, it's no longer listening to you. It would show you all the flights to Paris, and you then have to restart that whole sentence again. You can't say, "Siri, no, Berlin." It wouldn't understand this. And this is very unnaturally interactive. So instead of processing sentences and having this sort of strict turns, I'd like to process things word by word as you're saying it. On the first challenge, the sort of lack of data, we had an original data collection that spent about a year designing with people from Edinburgh Medical School and Alzheimer's Scotland. It was set for April 2020 and with this map task where we'd have 2 individuals sitting down having a face-to-face conversation. So as you can imagine, that is postponed for a long time. It's myself and my supervisor having a practice run, but we've mitigated now, and this is a device that I've been building to securely capture interactions between Alexa devices and people with dementia in their own homes. And this is actually ongoing. I have some data and some devices currently out collecting this data. So we're able to find, do people enjoy interacting? Is it easy to interact with Alexa? And when there's misunderstandings, are there particular phenomena in their speech that causes those misunderstandings? What's the most important ones to start tackling and to start adapting these systems? This is obviously a rather large process, and so much ethics and security involved that we've got a whole paper. I published a paper at LREC's workshop on ethical issues with Pierre from Edinburgh University on this topic. So people who wanted, a computer scientist who wanted to collect data from people with maybe head trauma, for example, can now follow this guide to ethically and securely capture this data, but with not taking a year to get the approval, basically. And so that's published there. Now this other challenge, this natural interaction, I'm talking about word-by-word processing. And so why is this more difficult? Well, the first step of voice assistants is to hear the voice and to translate that into text. So it's called speech recognition or speech to text. And we would like to do this word by word. So if someone's talking and they say, I want to cut an edge, and you don't quite hear that word there, you could say, I want to cut a hedge. It's not edge. Hedge. I want to cut a hedge. It would be a reasonable guess here. But if you have the whole sentence, like current systems, edge of cheese, it's a wedge. You want to cut a wedge of cheese. So these future words help you determine words that you didn't quite hear correctly in the middle. And so that's why it's a harder challenge to do this word by word. So this is a paper published at Colling 2020 with Arash, Eshghi and Yanchao. We evaluated current systems. So we took sort of Microsoft, IBM and Google's incremental, so word by word speech recognition, and we tested these on natural conversations over the phone. So on the same data set, the one that takes the full sentence were at human level performance. They were very, very good. Whereas the ones that were doing word by word, they were getting almost a third of the words wrong. Now they're all roughly the same. I'm not going to go deeper into this paper, but there were lots of experiments we did to find that Microsoft was the best for our use case currently, but that none of them are yet completely suitable for sort of word by word processing in a conversational agent currently. But we have this text and we want to do that word by word, but we also want to understand what the user is saying word by word. And this is what my supervisor and myself are working on at the moment. So this is maybe going to be published at the Reasoning and Interaction Conference. I find out tomorrow, so fingers crossed. But if the word Jane is said, we have this circle here called an entity. We know that it's called Jane, we know it's a person. So we have this person Jane. But when the next word is said, drinks, we now have Jane drinks. So we have this action, this drink action. An agent, the person that's drinking is Jane. And the object is currently unknown. We know there's an object there, but we don't know what Jane is drinking. Could be soup, could be lemonade, we don't know. Jane drinks water. Well, we now know it's water, so we can describe this entity by Jane is drinking water, and Jane drinks water quickly. We can then modify this drinking action to sort of say that Jane's not just drinking water, but at a pace. So this is a visual representation of what we're wanting to work on. We're trying to build this system that will, as words come out, we can build these graphs of what's happening to understand what is happening as words are being said. And that's currently in ongoing coding it at the moment. So a long way to go. But this first paper is on some of the formal definitions that we want to do. I also have been supervising 2 groups of MSc students with Oliver Lemon, and it's been a fantastic experience. They're really, really great students. So we had 2 groups this year, both towards the challenge of building a voice assistant for blind and partially sighted users. So I alluded to this earlier. But, what kind of questions do people ask? Well, this is pictures taken by blind and partially sighted people with the questions that they asked, and then the answers were annotated by volunteers afterwards. But does this foundation have sunscreen? What colour is this? Is it sunny outside? And you can see that a lot of these have text, which is important for later. We had 2 groups. So one group worked on spatial navigation. So where is my wooden spoon? The system responds with is just to the left of the microwave. Now we use the microwave here instead of it's just to the left of the fork, because that would lead on to where's the fork. Microwave is a stationary object where the user in their own kitchen will likely know where that is. And what about my green chopping board? Oh, that's just between your two hands. Again, we can use hands as a sort of relation in space because the user knows where their hands are. So this is also maybe going to be published at Reenact 2021. Find out tomorrow as well. But it was a fantastic sort of system that the students got working and developed these anchor points like the microwave, oven, things that the user is very likely to know where they are in the kitchen. And the other group worked on sort of this text in images. So we had that can of soup in the example before. That sort of almost middle one there, butternut squash, red pepper soup. So I'm a vegetarian. Can I eat this soup? No, it contains sausages. So in this scenario, vegetarian can't eat meat. Sausages are meat. And it's very easy for a human to answer this question. For a system to get that from the packaging in the image, it was a very interesting process. And this is me published at ICMI 2021. Is my curry safe to eat? It doesn't contain meat, but it expired yesterday. So again, we're using expiry dates because we're safety, but also remembering that the user is a vegetarian. So again, that paper will be coming out soon, and I'll announce that on my Twitter there, but also LinkedIn. And I do release Medium publications. So academic papers are great, but they're often targeted towards sort of specific groups of academics, so lots of jargon, for example. So I do tend to try and write Medium articles on a lot of these things, just for people in other fields, people who have a passing interest, and hopefully I try to not use jargon, explain some concepts and stuff like that. And it's really fun. I really enjoy writing more casually and explaining sort of the exciting things that myself have done, and MSc students are again. It was really, really fun to work with so many great students this year. And I detail all their names and LinkedIn profiles and stuff like that there. But yeah, thank you very much. And I think I'm going to take any questions in the sort of question area. Thank you very much.